Welcome, everybody. So we got Saumil Shah today. He's a big friend of Hack in the Box already since the beginning. And I'm not going to talk a lot about him. I'll leave it to him. Welcome, and this is Innovative Approaches to Exploit Delivery. Welcome, Saumil.
Thanks, Barry. My goodness, this is the reason why I love Hack in the Box. It's a great crowd, great audience, and this is my 12th year in KL. Always enjoy being here. So much that now it feels like home. All right, so what are we going to talk about this next hour? I'll give you a quick introduction of myself, slightly boring stuff. I've been doing a whole lot of security stuff for more than 15 years. And the older you grow in this industry, you tend to become bitter. So just to, show my bitterness, after this talk, I'm going to head over to the panel and start drinking on stage. That's what everybody's doing next door, too. So the deal is you ask a question in the panel, you get a drink, we get to take a drink. Anyways. But I've done this for a long time, and I started off with Unix hacking, went on to web hacking, sometime close to when Jeremiah started web hacking as well. Jeremiah is still great at it. I tended to drift away. I got bored of it, but I still tend to get back to web hacking from time to time. Mid-2006 onwards, I started playing with exploits, binary exploits, which was always my passion, an assembly language, and started building browser exploits as an area of interest in research. And what this talk is going to be is, I've always wondered what it would be to combine the two forces. On one side, you have all the cool stuff about web hacking, which I really like, and the more I dig into it, the more innovative it gets. But kind of frustrating. I'll give you an example. For all the demos that I had to do today, the return-oriented programming exploits with all the ROP chains and the defeating ASLR and DEP on Win7 took less than half the time it did for me to struggle with bloody JavaScript and HTML and making sure the stupid images align properly, and if you do an on mouse over, things happen here and there, the goddamn browsers don't crash. But I finally got it working, and I hope the demos work. So what happens when you combine web hacking with binary exploits? You get a pretty deadly mix. On one hand, you get all the sneakiness of web attacks, because web attacks are really sneaky. You have all stuff going over HTTP, and all fancy stuff running in browsers. And I'm sure this one's going to be especially hard to follow after Jeremiah's talk, because he's already talked a lot about it. And then, with the sneakiness, you also get the lethal weapons with the binary exploits. So a lot of exploit writers who write exploits, they write exploits and they throw it up there. Cool, What do you do after you jump through all the ropes and do the whole escape of Tai Lung trick from Kung Fu Panda prisons and whatnot? You launch a calculator on somebody's system, yeah? I mean, calc is, after all, as, I don't know if SK is here, but as SK says, the hello world of all shellcode. And, when you combine, this is really plain dry exploits. It's cool. It's a calc, it's a shell, awesome. But you really need to sexy it up. And that's what we need to do with all the web stuff. So it's time weapons like these get some help from people like these. We want to combine the good stuff with crazy things that happen with 302 redirection, especially with URL shorteners. We want to deal with attacks by using images. I personally am an artist at heart before I started doing all the computer stuff, and realized I couldn't make a living as an artist or a calligrapher, which I'd really love to do if I retire. But yeah, art with exploitation is something we're going to talk about. We're also going to talk about JavaScript. And I think if it's 2012, I better throw HTML5 for the bloody buzzword in there anyways, right? HTML5, cross-site scripting, yeah. OK, cool. But yeah, the exploitation does involve some help from HTML5. And in fact, the hole gets deeper with HTML5. So with this, we're going to first start talking about shortened URLs. This is a trick that I pulled off a few years ago. I just want to show you really quickly what kind of stuff can URL shorteners do if coupled with binary exploits. So let's talk about the joys of short URLs. Simple example, we had an SMB URI overflow in Videoland player a few years ago. Quite a popular media player. Everybody has it. Everybody watches Pirate Bay downloaded. Oops, can't say Pirate Bay. Poor guys. I hope they're not like really screwed somewhere else. I feel for them. Yeah, so, well, screw it. I pirate movies. So what? So yeah, you watch all this sort of media on VLC. And VLC can play anything. So one of the buffer overflows was a big, long track listing. Now, this is not a really cool thing to exploit if you want to start grabbing a lot of people and owning them in your botnet. Because if you want to send this exploit around, guess what? You have to actually create an XML file, which, I mean, I really struggle with XML. I'm allergic to it. And then you have to put the track name in there and then create a playlist and email this playlist to your friends and say, hey, click on this playlist, and then you'll get a shell. Nobody's going to do that. So we figured, let's try to convert this exploit around to a sexier format. So we use the power of URL shorteners plus the power of purely alphanumeric shellcode, and then you have something where tiny URL is hosting your entire exploit. This is still up there. This is still live. YCCTRZF. This is the URI on tiny URL, which will, if invoked, which will return a URI like this, SMB : blah, blah, blah. It's 2012. They still don't care if they're replaying back HTTP or not. You can send back SMB. You can send back FTP. You can send back Saumil : // You can send back anything. It's a 302. Tiny URL doesn't care. And with this, we achieve some crazy effects. Let me show you. So let's see. OK, pardon my lame Windows XP demo, but this is the only XP demo that I will give you, I promise. Let's preview tinyurl.com. YCCTRZF. I have it memorized by now. OK, so here is, goddamn no script. Great. For the demos to work, you have to allow everything. Yeah, there we are. This is the URI. Now, see what's going to happen if I launch VLC with it. So the request I'm going to make is, hang on, let me wrestle with the second screen. So what I'm going to do is point the browser to a web page which serves an embed tag with a tiny URL. So this tiny URL is going to be fed to VLC. And then when VLC makes a request, it's going to expand. And if you look at the network trace, it's going to expand to this big, giant exploit. And let's just see the net effect. Incidentally, recently, the whole the USSD exploit for Android phones came out, where you can do a tell URL and tell : something, something, where you can wipe somebody's phone to factory reset. I'd be curious to see how many tiny URLs or short URLs were registered with the, and what are the stats on it. That would be really, really fun. Like how many people got owned that way. So anyway, here's a play movie. Let's load this up. Now, this one has an egg hunter. So I don't know, a lot of people think egg hunter is the biggest thing around in exploitation. It's just a damn shellcode. But in a little bit, after it finds a shell, there we go. Pops calc, your browser is owned, and welcome to the botnet. So yeah, alphanumeric exploits through URL shorteners. Now, if somebody is going to get busted for hosting the exploit, it's not going to be me. It's going to be tiny URL, because the code's on their side, not mine. I mean, incidentally, you can play a lot of tricks with URL shorteners. there was an article I wrote in the Hack in the Box e-zine a couple of years ago talking about all tricks you can play with shortened URLs. OK, on to more exciting stuff. All right, I'm going to just do a one-up on 50 Shades of Gray. I have something called the 255 Shades of Gray exploit. We are going to do exploits using images. You have a whole bunch of JavaScript which gets detected, which gets filtered, which gets signatured, which gets through all sorts of crap. But images are images. Nobody thinks images are really bad until they're really, really evil. So how would we do it? Well, we encode the entire script. We encode the entire JavaScript character by character using their ASCII values into any value from 0 to 255 and use these as pixels in a perfect image. So what you get, your exploit is going to be something like this. This image is your exploit. How does it work? Let's see. So let's see how this whole thing works. Basically, I've also written a little converter. So if you type in all your JavaScript here, and then you click the convert button, you'll get a PNG created, which you can then load and decode. And let me show you how it's all done. So right, let me load a browser. And here I have the converter. So let me just give a very simple conversion thing, like simple JavaScript, and let me show you how it's going to be encoded. Simple enough, alert document.date, alert document.location plus date. If I hit on convert, you see a little square thingy appears over here. Let me zoom in for better detail. Now, this is a 7 by 7 square with all these gray pixels in here. Each pixel corresponds to one character on the JavaScript. Now, this is a perfectly legit PNG image. This can be hosted anywhere. This can be thrown around on anything, Flickr, Facebook, image bucket, whatever it is, photo bucket. And then all you have to do is you have to load it on the target browser. Let me show you the decoding test. You load it on a target browser, use an innocent JavaScript to just do some image processing, which is, you can use a lot of, one moment. Yeah. You can use a lot of JavaScript toolkits like jQuery or whatever to do the same as well. Let me see, there it is. So yeah, here this thing will load up the little image, and then you can click decode. And here the same string that was encoded is decoded. And now how do you execute it? Well, you take this, and then you eval it. Right? You take the string inside JavaScript, and then you eval the whole thing. So let me show you the eval bit. So here's the eval. I'll show you the source as well. So here's what I'm doing. This script called PNG data. This is a script that basically takes the PNG image, decodes all the pixels by pixel. We use the canvas tag for doing this. On canvas tag, you can load an image and go through each pixel value and get the colors and RGB and whatever. And then we assemble the whole exploit. And once we do this, we can throw it into something like, yeah, take the decoded text, put it in an eval, and then the whole thing will run. So now you've transported all your dangerous part of the exploit over an image, and all that remains here is the innocent part. Let's see how this works. So I click on eval. Sure enough, you get an alert. Let me do like a slightly more complicated one. I mean, again, my knowledge of JavaScript is very poor, I'll confess. So doesn't get more complicated than probably this. OK, so now you get another image. Let's reload this guy. So here we go. Now it's just going to create, so every time I click eval, it's going to create a div in my page and just run arbitrary JavaScript. Using this technique, we can actually do quite a lot of evil stuff. First, I'm going to show you the pure version of the exploit, which is, yeah, this is not encoded. This is plain vanilla, dry, boring, non-interesting, calc popping exploit. So let's see that. Here is this exploit. It's a slightly older exploit on Firefox, but it's still sophisticated enough that we have to use a lot of return-oriented programming, pack the shell code, launch calc, and it's a use after free exploit. This is as is. So let me show you how it works, and then we'll use the encoded version and give it a shot. So where is it? ffrop calc. This is the one. I mean, it's going to load. It's going to do the heap spray. It's going to do, it has to pretty much like an 800 meg heap spray for it to work. And once it does it, oops, let's continue with the script. Once it does it, pops a calc, system owned. This is the old way of doing it. Let's see a more sophisticated way of doing the same thing. So what I'm now going to do is take the JavaScript of the exploit, which is all this use after free stuff with the shell code and everything, copy it. We will paste it in the encoder thingy, get a nice PNG out of it, and then use the PNG for the exploit. Go. So pasted all the stuff here. Convert. This is the image that you get with all the encoded gray pixels. If I were to decode this, take this and decode, you get the same thing back. Okay, let's use it in a production exploit. So now, all the ugly stuff of transporting the exploit code has been transferred over to the image. Inside the JavaScript, there's nothing really evil, per se. I know Jeremiah is going to call me on it and say, well, eval is evil. It is. What can we do? Necessary evils, right? Yeah. So here is the encoded version. I've programmed it so that it triggers when you do a mouse over it, just for the heck of it. So here we do a mouse over, and then if it all works, which I'm hoping it will, calc. So the concept does work. Okay. So what we did was we basically used the canvas tag, started reading all the pixels, and assembling this in memory, and then evaling the whole thing. And that popped the whole exploit straight away. There's a lot of tricks you can do with images. You can preload them. You can cache them. You can load them through other sites. Once they're in the cache, then your browser doesn't even need to make a second request to load the image. It all just pulls from the cache. And there's also ways, especially if you're using QR codes, you can even resize the images or stretch them or even distort them a bit, and the original content won't be lost. Right. So with that little bit, I want to then I was trying to struggle with removing all evil from the JavaScript. So we want to see no evil. We don't want to have any eval in the JavaScript as well, because I've been told by a lot of AV, okay, no adjectives used here, AV vendors that there's signature eval, and they look for all sorts of eval decode, so they can stop multiple decodes. Hunted around a little bit, had to go back to closures, and found out that you can do eval without using eval entirely. So what used to be something like this can now be in one line translated to a constructor, to a function constructor. So you just construct a new function with the same string and invoke it right in there. So this will have the same effect as eval. It'll execute the entire string. There's no eval in the code. There's no signaturing. All that arguments just stay to rest. And as a proof, I'll show you this no eval trick. This has been pretty successful in the past for me, I will say this. Get out. Firefox always tries to restore the last page. So where is it? Let me put some sample data in there, and then we'll do the eval, just to show you. OK, so this is converted. Let me do the So here is the one without the eval. If I show you the source code. So here in the exec data, previously we used to have f equals eval something. Now it's replaced with f equals new function decoded test. There is no eval except for this little string on the button. There's nothing in the JavaScript entirely. So if I click this, works the same way. Absolutely no difference. So now we're getting stealthier and stealthier, and the loader script's looking way more innocent. In fact, it's actually not doing any malicious or any evil or crazy JavaScript stuff. It's just doing simple things. All right. One more trick to discuss. I've also been wondering, can we represent JavaScript itself in a different way? We can wrap JavaScript as pixel data and then decode it back to JavaScript. But what about the loader JavaScript itself? Can we hide it? Can we do something really crazy with it? And I was always fascinated with the idea of Chameleon Files. You guys heard of the GIFR attack? You can have a GIF file, an image, and then have a zip file at the end, like a Java archive, because the zip headers begin from the file bottom. The last bytes are the headers, and the GIF headers are at the top. So you can have a file which is a perfectly valid GIF file and a perfectly valid jar file. And you can load a GIF file and then instantiate a Java applet and really wreak havoc with it. Billy Rios found this out a few years ago and presented it at Black Hat, and that got me thinking that can't we do similar things using JavaScript? So Jeremiah, I showed you this thing a couple of years ago. So here it is, finally out in the public. This is what I call as chameleon JavaScripts, but I have a cooler name for it, images, with a notice the subtle JS at the end. Let's see this. Let's see this thing in action. I show you a simple page, and then let's see how it goes on. Images demo. So see what happens if you move the well, you got to have the good admiral in there, right? Now the source for this is really crazy. Oops. Okay, I know it's a trap. Stop. This is 2 lines. Yeah, check out this stuff. The source is a GIF. The image is a GIF file, and the next tag is script source equals the same thing. The browser will load the image once. The second time, it will use the same object in a script tag. There will be no network request made if you do the cache control right. Once loaded, it will be re-invoked. And how does this happen? Well, There's no rocket science here. Let me share with you straight away. What we do, I'll show you how the GIF file is made. See, typically, GIF files always begin with some GIF header, right? You have something like GIF 89A, and then you have the height, you have the width, and then you have all this other run length encoded gobbledygook data. So all you do is replace the height with 2F2A hex, which translates to /star. At the end, put // equals 0, and then put any other shit you want. This is a perfectly valid GIF file. This is also perfectly valid JavaScript because you've assigned a variable GIF89A equals 0, and then added your JavaScript stuff at the end, ignoring all the image stuff in between. This works like a dream. So it's a neat little trick. Thank you. It gets better. It gets better. Let's see this. Let me show you the GIF file. So if I open up the GIF file, here it is. Now, incidentally, browsers and other image processors don't really care if you screw up with the height or width. They will still take the exact image data and render it properly. So you can go about screwing around with this as much as you like. So here it is, the GIF, all the stuff in here. And here it is at the end. You see this little bit. Yeah, there it is. So it's simple. I mean, I haven't even obfuscated this JavaScript. I just appended it lazily, even with the comments, and it works. So this is the same thing that I wrote. The moment you load this JavaScript, it does this. It's a trap thing and goes ahead. I did some R&D on this. I actually dug in and thought, let's see how well this works. So I did some comparisons. This stunt works very well with GIF files. And so far, all browsers except IE render the GIF file properly. IE actually obeys those height headers and screws it up. Well, you can't fault them here, right? They're actually doing the right thing. But yeah, they will still execute the JavaScript. Even this image will render properly on your desktop preview application. So if it's sitting in the cache and somebody clicks it and sees it, they won't see anything evil either, except the XP renderer doesn't really work. There's a better format for all this, though. I tried with PNG. PNG doesn't work because it has a 0, 0 in the header, so all the things truncate. But good old BMP, good old fat bitmap files, everything renders, everything executes. BMP files are great for this whole stunt. So yeah, this technique has a lot of promise. I'm sure there's more creative things people are going to do with this. And I was thinking, OK, now we have this shades of gray exploit loader, but we have a pure JavaScript. Why can't we combine both of these techniques together? So one image to carry the exploit, another image using images to decode it. And I got even a step better, no more shades of gray. Is Dr. D here, Dinesh Nair? Because I want to, this being the 10th anniversary of Hack in the Box, and Dinesh being an ultimate guy who also co-founded this whole thing, this exploit's dedicated to him. This is the AlphaQ exploit. That's his Twitter handle, by the way. Why? Because I'm using the alpha channel. If you don't use the pixels, but you use the transparency channel in the image, it's even stealthier. The pixels remain there, but the transparency values change. And you can encode the whole thing using an alpha channel. For example, here is an exploit using an alpha channel. See it? OK, let me show you. If you notice very carefully at the top, yeah? Oops. I have a zoom in thing. So if you look at the top section, see all these little pixels that are garbled up? The top couple of pixel rows have the entire alpha encoded exploit. This is not alphanumeric. This is alpha channel encoded exploit in there. So if you combine the two, images with alpha Q, well, guess what? Let's do this. Let me show you how this stunt works. Now is the time to actually really read my notes, because if I goof up, the demo is going to go bad and I'll look like a fool. Okay, so what we do is we take the same exploit that we did, the Firefox ROP exploit that I had, except that I'm going to compress the JavaScript. And the compression is nothing strange. I'm just using the Yahoo UE compressor script. So all it does is just eliminates all the comments and spaces and packs everything nicely. So here is the compressed thing. Copy it into the clipboard, and let me paste it on an alpha encoder. There's something called make canvas. So here, since we're talking about art, right, you had to guess this is going to come up. And me being an artist at heart, how can I spare this one? So paste this in, embed it. Oops. And here you can see the pixels nicely encoded. But I mean, come on, who's going to look at the pixels, right? In this one. Now this image is going to carry our ROP exploit over. And as an added bonus, well, let me show you how this goes. Let me not. So here this is created, and let me pop open the exploit. That's the grub laughing. I can hear that. Okay. Okay. So now here's the beauty how this works. The decoder script is embedded in this GIF file. And so let me show this GIF file if I can. So this GIF file that is loaded contains the decoder script. Here it is. This is the load image data and read all the alpha values and everything. That's over here. If you look at the source of the exploit, source is very, very minimal. Now all you're sending across is nothing but 2 GIF files. The exploit is also loaded, but I've set the visibility to hidden. So the whole thing gets preloaded. The GIF is loaded, that is the decoder script, because I'm also loading it as an image, and I'm loading it as a script. So everything's set. There's nothing strange in this entire HTML. This is safe. This is innocent. This can be pasted anywhere. All it has is a couple of divs to hold the content, and I'm sure I can do it dynamically with my JavaScript better, which I don't, and I don't intend to get better at JavaScript either. OK, so net effect, let's see. So if you try to restore this fresco, here we go. And this has an on mouse over property, which will decode and pop a calc. So yeah, you combine these two techniques together, exploit delivery by images, image decoding by images as well, and you get pretty damn lethal effects. Yeah. You want to have some questions in the middle before I go on to the next stuff? Anybody? Come on. Let's have it.
Why bother with
The question is, why bother with the preloading of the images? You don't need to. I just did it for the slickness of the demo to switch the two frescoes on the fly. Preloaded images have one advantage in the fact that these get cached. If you do the cache control headers right, these will then stay on your browser, and the next time you refer to them, they'll be just pulled out from disk. So I may have sent you some photographs yesterday, and I exploit you today. You probably won't know where it came from unless like you're really digging hard and try and correlate both the things together. So yeah, I mean, once it's an image, we might as well preload it, is what I've learned. OK, so with this, I have actually any other questions? Anyone? Yes?
Are we going to talk about how to protect from these attacks?
Are we going to talk about how to protect from these attacks?
Yes.
Yeah, I'll talk about it. That doesn't mean I can do much about it. As we can see, these are not the exploits you're looking for. Yeah? One last demo. This I did. This is an old exploit, right? This is an old libtiff exploit on Acrobat 9.3, 9.4. The exploit that got published was using a really weird ROP chain, because when you load the TIFF file, you can't, I mean, you could try a heap spray with it, but the moment you load the TIFF file, the heap spray was getting destroyed. Like the JavaScript was getting garbage collected, and unused objects were getting released. So the guys who wrote the exploit had to use some really clever ROP chaining, until I dug down and figured out that typically all Acrobat JavaScript is written in like a launch object in the PDF file. And I started reading about Acrobat forms, XFA. It's a nightmare to go through those XFA documents. First of all, it's XML, which I really hate. And second of all, it's Acrobat, which I also really hate. And third is to get this XFA work in PDF is a big pain. But I did get a very, very smooth heap spray working in Acrobat PDF. So the whole TIFF exploit got converted into a really simple exploit with the heap spray. That alone was enough to defeat all the signatures. So 3-year-old exploit worked. Then the signatures got a little cleverer. So I decided to get cleverer against them, because one of the things that I always never miss a chance to expose is the whole folly of signatures and rules and auto updates and this whole stupidity that has got our whole industry hooked and shackled with all these subscription models. It's 2012. These things don't work anymore. How many times do we have to prove this on stage? One more time. OK. So let me show you this little piece of work. Oh, man, why are you preempting my stuff? Anyway, Fyodor hit the right solution. Yeah, you can encode them as XDP as well. And all right, since you've done it all, let's get on with the demo. The demo is pretty slick. So I did this as a test. I emailed myself a copy of a malicious PDF file this morning on my Yahoo mail. If you guys are going to mitum me and sniff me, I don't care. This is a junk email address anyway. The grug? He popped it. Oh, cool. Wow. All right. So here, let's see what we have in the inbox. Here it is, for your reading pleasure. A PDF document, guess what, of all the things. Let's open it. Of course, it's going to say libtiff calc xdp, but ideally it should say, the news report from Hack in the Box or something. I was lazy, I didn't rename it. Click it. Oops. It says open. Wait, before it says open, let me show you this thing. Norton Antivirus live, running on bloody Yahoo. All right? So yeah, you first layer you do is Acrobat forms. Second layer you do is just make them XDP. XDP is nothing but base64 encode and put it under 2 XML tags. It's simple, it's trivial. But that alone gets you cal. So, I mean, and who knows where we can go by embedding alpha encoded images inside PDF. The possibilities here are tremendous. You have a number of options thrown open from the web world. Browsers support a lot of weird standards. There's too many components at work. There's too many things that are actually influencing the DOM. I've always asserted that browsers really fundamentally need to change the security model. Today, we're loading everything under one DOM, all untrusted sources. Any loaded object has the ability to call any inbuilt component of the browser. Like if I have the LinkedIn toolbar, a JavaScript can instantiate an object on the LinkedIn toolbar, even if I wouldn't know about it. The whole security model, a lot of people compare the browser as a next operating system. If that is the case, you're right, it's Win95, or as I used to say, it's DOS. It's like one, but it's Win95 because now we have two processes, one parent process and one child process for all the tabs. But they share all the DOMs, and it's cooperative multitasking anyway. So unless we really change the browser security model to a more privileged enforced model, this is not going to improve. Secondly, you talked about protection. I have one thought on protection. Bugs are going to be around. It's a fact of life. I mean, we are sitting here, right? You see there's people popping shells around you, fresh shells, walking away with 60 grand. Pinkie Pie did it yesterday. Big cash prize. Does it mean to say that Chromium is insecure? And it's as secure or insecure as any other piece of written software. What I would say makes Chromium secure is the fact that they had an update in less than 1 day. Your turnaround time, your reaction, your ability to detect and respond and stop this the moment you see it happening or as early as you can is what's going to make you secure. Preventing an exploit, yes, there are technologies like DEP, there are technologies like ASLR, but as I've said in my previous talks, the bar keeps getting raised higher and higher, and folks like those sitting with you are getting more and more creative every day. Every day is a new challenge, every day is a new platform. You make it hard enough, and we will work hard enough. That's how the game is. Naturally, it's not like everything's owned. The window is definitely shrinking. I mean, today, if you want to exploit server-side software on ASLR and DEP, it's not an easy task. I mean, previously, you used to have RPC exploits and FTP exploits and all sorts of tricks, like Oracle exploits and all. Today, predictability has gone down pretty low, unless you get really creative. Most of the bugs you're seeing are browsers and PDF. Well, guess what? They're both shitty pieces of software to begin with, and we're hooked to them. So for as long as the world uses them, that's OK. This is going to happen. So I know I haven't really answered your question well, but this is the best I can do. What am I going to be working on in the future, or what do I think is going to be the future in this whole exploitation game? To get more creative, I'm definitely keen on exploring HTML5 video, SVG, and all the fun stuff with SVG that goes on. WebGL is another big one, because that can also open up a lot of GPU and DMA type of stuff. There was an exploit where you could actually do screen grabs of Firefox just using WebGL. Like somebody remotely can get pieces of your video memory thrown back. Brilliant piece of work. And the game will begin again with mobile browsers. Browsers on phones, browsers on tablets. Here, the fields, it's sort of like going back to when Hack in the Box began. The same game, the same circle is going to repeat. Probably Hack in the Box 20 will talk about such mitigations for phones, and then there'll be something else to play around with. So this pretty much brings me to the end of my talk. We have a few moments left for questions, comments, suggestions, any ideas on how to protect or how to go further breaking. It's all welcome at this point. My demos are all done. Thank you.
If you have any questions, just raise your hand and we will come to you with a microphone.
Yeah, hi. Would Sandbox be actually, and running the browser in a sandbox environment would be an easy exit for those kind of stuff?
Sandboxes raise the bar, but they're not the be-all and end-all. Because after all, the browser's got to work with the operating system in some way or the other. And yesterday's exploit is a fresh example of Chromium with all its sandbox getting busted and local privileges being escalated. So it does raise the bar, but sandbox is, at best, a sandbox, right? You play in it, but then you don't do anything else in it. I don't have much faith in sandboxes. They make it very challenging, but it's not a bulletproof measure.
But you need to exploit the sandbox itself to get to the OS.
Let's talk about exploitation today. Today's exploits are actually compound exploits. To do something like a shell on Chromium or a shell on IE, you may need more than one defect to be chained together. You probably need a memory read bug. Back in the day, a couple of decades ago, we used to scoff at memory, like, haha, reading arbitrary memory, who gives a damn, right? Today, memory read bugs are worth their weight in gold because now you can leak pointers, build up ROP chains on the fly. So the depth part is taken care of by return-oriented programming. That's a done deal. It's going to be, unless we change the whole way of stacks and frames and all that, that's going to stay. ASLR, you defeat by info leaks, memory leaks, and pointer inferencing, which is also quite popular, and there's a lot of work being done in the area. So that gives you EIP control on the browser. Next thing you need to do is bust a sandbox, and that you do by leveraging a few APIs. And that's happening. So you probably need 2 or 3 defects to be chained together to achieve a working exploit. But as is demonstrated by a lot of these contests, it happens with non-negligible probability. Sometimes you even find exploits in the wild doing this. The IE exec command used after free found last month floating around. That popped shells on IE 7, 8, and 9. Happens.
Thank you.
Any other questions?
Suggestions?
I see enough people for questions. Huh?
Oh, all right.
Nobody?
Oh, come on.
Come on.
Well, then, yeah. Do I have one?
No. So just a weird observation.
Yes.
You can see how, with the sort of context segmentation and the like that they're trying to put into browsers and the like, that what you're actually doing is just replicating sort of the sort of compartmentalization that you see in operating systems in the browser. And you end up with a sort of like weird snake eating its own tail sort of situation where you're just piling complexity upon complexity upon complexity, and essentially it's a cycle with no end.
If you look at browsers, yes, it looks like complexity after complexity after complexity. But if you look at operating systems, when they're done right from the ground up, with the concepts of time slicing and process virtualization in mind, these never were in the browser to begin with. We can't go and throw all that away. We have to live with all that crap, so we keep on bolting.
Can't, I mean, one of the things that's really apparent when you look at the mindset with which HTML was originally designed.
That's right. It was built by a few guys looking at small particles going round and round deep underground in Europe.
And the problem is that the design paradigm is just simply all wrong.
Indeed.
For this sort of thing. It's like there's no like the language itself doesn't have any context awareness built into it. It doesn't have things like Like at its very, very basic level. It doesn't have, the ideas of like, inherited context and things like this. It just isn't there.
Yeah, you're right. And in fact, this you'll almost get me started again on all these type of things. But we've had this conversation a number of times. But yeah, it's okay. I'm not going to pop up my my Mario and the princess slide on how the gap is still not bridged. But it's there. You can Google it up and see. Yeah, we're far away. We have to relook at the purpose of browsers, at the purpose of web applications, how we're using and consuming web applications. We need application isolation. We need privileged containers. We need the equivalent of syscalls in browsers. We need a lot of protection applied at the browser layer, the same concepts, virtual DOM environments. But we'll have to do away with a lot of stuff that we're using. We can't carry over the old legacy and add this on the top. We have to go back and undo a few rotten things. I mean, come on, Emerson, IE6 is still alive, right? You can't kill the goddamn thing. Microsoft can't kill it, even if they want to. So unless like we nuke all the roaches, but oh wait, they don't get nuked either. Right. Okay, he's flipped out. Anyone? Okay. If
Thank you
not,
very much, Saumil.
Thank
Give him
you.
a big applause.
Thank you.